idea now. Now you should really get into the basic things here now. Okay, now let's get into some fluids. Suppose there is a solid which is floating. So it is floating in a liquid. This one. So the density of solid, let it be sigma s, I'll write it. That of the liquid, let it be rho L, or rho S, will write it. This is a temperature, theta 1 degrees Celsius. I'll write the temperature. Both solid as well as liquid will expand. When both will expand, then what conditions we have to follow? What will happen to fraction of solid immersed? You can see that the size also got increased and it got more into the liquid. No, so we don't know under what conditions it'll go there. We have to bring that one. So what is the basic necessary step? So the buoyant force FB and the weight. The weight will not change. No, mg will remain as it is. So now I'll increase the temperature FB dash. But you look at the length immersed, or say fraction, or say like a volume immersed, it may change. So here if you write say H1, earlier it was having area A1, now this will be A2. Density of liquid, how much it will be? Rho L dash. Density of solid, it will also change, rho S dash. What all happened? Let's see that one here. So let's come to the fraction of volume immersed in the liquid. So what do you mean by fraction of volume immersed? Volume of anybody? I think we completed buoyancy.
Volume of solid by volume of liquids.
Volume of solid by volume. That's the meaning. So now we'll define here fraction of. So F, okay, let me write this. F and F dash are the fraction of volume immersed at temperatures theta 1 theta 2 degrees Celsius. So how you define F? So we'll define like this: F equal to density of solid by density of liquid. Okay, this fraction you should remember. Now what is the new fraction? F dash equal to rho S dash by rho L dash. Later we'll see H1, H2, all the numericals. So I'm interested in this one. So how we define rho S dash should be equal to rho S by 1 plus gamma S delta theta. Similarly, what is rho L? 1 plus gamma L delta theta. So this will become rho S by rho L 1 plus gamma L delta theta 1 plus gamma S delta theta. Rho S by rho L, what you can write? F. Okay, there's a basic formula for okay, delta theta. What is delta theta? Change in temperature. Okay, that 1 minus I'm trying to avoid here. Let it be in this particular form. Okay, no. What will happen to fraction of like a fraction of volume immersed? Will it increase or decrease? How do you can say if gamma L greater than gamma S? So let me put all the conditions. Okay, fine. Able to get this one. So first case, gamma L greater than gamma S. Then F dash will be greater than F. Solid further sinks. So what will happen? It will more volume will be further immersed here. Solid will be further immersed. What do you mean by further immersed? Further it will go into more into the liquid. If gamma L equal to gamma S, F dash equal to F, no effect on no change in volume, no change in volume immersed, no change in volume immersed. And then if it is a gamma L less than gamma S, if you rise the temperature, the solid lifts up. Or what you can say that one? Suppose say 5 centimeter was immersed. If gamma L less than gamma S, then what happened? The volume immersed, the length immersed will be less than 5 centimeter. Maybe it is 2, 3. It will solid lifts up. Solid further gets immersed. Further or solid rises up. I'll write it. So simplest idea, volume immersed decreases, volume immersed increases, volume immersed decreases. No change in volume immersed. Solid rises up means what is another meaning? Volume immersed will decrease. There's a meaning.
Sir, that is not raises up, no, sir. First case is volume mass increases.
Oh, volume immersed. Sorry, rises. So solid. What we should use? Rises up only it will come for no. Solid lifts up.
Liquid rises up.
No, no. Solid moves down. You write it. Some terminology we have to bring it. No. Solid moves down. Or I think volume immersed. I'll put it. Volume immersed increases. This will be better. Volume immersed increases. The solid lifts up or volume immersed decreases. Different ways they may express. That's why I'm trying to put that one. Okay, these are the some basic definitions is what we are bringing it. Suppose if you know fraction of volume immersed, can you bring the gamma or any other quantities? Can we correlate? There's a one definition like this. So if they ask you what is f dash by f, so can we write relationship between them? I think there's a simplest formulas, no, which if you can remember. In books, you have questions of these kind. Just you should know the basic definition. What do you mean by fraction of volume immersed here? What is delta theta? Change in temperature. If you know gamma of the liquid and the gamma of solid, no, so we can use this particular method. Just see once.
Why did we take rho s by, sir? Why did we divide rho s by that change, sir?
That is a formula, no? Density of the liquid will decrease with the temperature. Rho equal to rho 2 is equal to rho 1 by 1 plus gamma delta theta. Yesterday we have discussed, no?
Yes, sir.
Based on that, yeah. Because both the liquid and solid will expand, no? So the density of substance should change. So what is the density of a substance at any temperature?
Sir, if you use binomial expansion there, answer will change, no, sir.
It will come. See, you are just making the formula. Then the formula. Don't go for binomial expansion here. So 1 plus gamma f delta t. If you make there, 1 minus will come. No, nothing will be there. 1 minus of gamma f delta by delta theta, and this will become 1 minus gamma L. It will be of that one.
Means we'll get two answers, sir.
No, this is the formula. Don't go for binomial expansion. Binomial expansion should be done only when if it is gives temperature like that.
Yes, sir. Thank you, sir.
Formulas, please recollect formulas. Without yesterday's class, the density of the liquid will vary, no? Density of solid. So what is the new density? That formula is there. That should we should apply here. Okay, now we have this body, a solid. So now let me immerse a solid here. So it is immersed in a liquid. The density of solid will not change, whereas the density of liquid will change.
Sir, how can we know that when to use the binomial theorem and when to not? In that
Okay,
form?
so gradually you can see in the numericals. I'll bring the conditions. Okay, now you can see this. Volume immersed, the solid will not expand. It's the same diagram. Oh. I'm just showing that one. Look at the fraction immersed. Solid will not expand here. I will rise the temperature. Then density of liquid will change. So what will happen to the fraction of volume immersed? I want that rho L, coefficient of volume expansion of the liquid. Gamma L have to be determined. So let me give F1 and F2 be the fraction of volume immersed. F1 is fraction of volume immersed. Immersed or submerged, anything. Fraction of volume immersed at theta 1 degree Celsius. What is F2? Fraction of volume immersed at theta 2 degree Celsius. How you write the basic definition? Fraction, go back to the previous formula. So how do we write fraction of the volume immersed in the first case? F1 should be equal to density of solid by density of liquid. So similarly, what is F2 and what is F2? You can write it as density of solid by rho L dash. Because as you rise the temperature, what will happen to density of liquid? Has to change. Now density of solid remains same. Solid will not expand. This condition is given. So therefore, I'm writing rho S only. So now I want find gamma L of liquid. Coefficient of volume expansion of the liquid has to be determined. So let me divide this to F1 by F2 should be equal to rho S by rho L, rho S by rho L dash, or this is rho L dash by rho L. Any formula related to this? Rho L dash at temperature. So what are this one? At temperature, fractions are immersed here. So rho L dash should be equal to some rho naught 1 plus gamma L T2. What is rho L? Rho naught symbols, lot of confusion. What is the rho L? Density of liquid at theta 1 degree Celsius. Temperatures, okay, theta 2. What is the density, rho L dash, density of liquid at theta 2 degrees Celsius. So let me write in this particular. So this will become how much? 1 plus gamma L theta 1, 1 plus gamma L theta 2. So he's asking now gamma L. So let's solve this equation. F1 gamma L theta 2, F2 so let's simplify for this one. So F1 minus F2 should be equal to F1 F2 theta 1 minus F1 theta 2 gamma L. So what is gamma L? So like this, what happened? I can measure gamma. It's a very difficult quantity to measure gamma of a liquid. So these are the experiments what I'll be using. So so sir, why solid will not expand? So I'll just say wood. Wood will expand? Not there, no. Wood will not expand. We know that. So instead, if you put iron, so if you put some other material, yes, it may expand. So if a wood, what happen? Definitely, it will not respond for the heat change in temperature. You do get varieties of questions with the fluid statics. Only the density of liquid, as you rise temperature, density of liquid should decrease. That is enough. And the basic fluid statics, fraction, what do you mean, fraction of volume immersed, density of solid by density of liquid. Now it can happen that can we have a situation? I'll bring a really very good question. You can see now. So let me have a cylinder. Okay, let me take cube itself. Now I'll rise the temperature. This one. So quotient of expansion of the liquid is this one. Let this be gamma S. Density of liquid, density of solid, these are. Then this is at theta 1 degree Celsius. Okay, fine. So I will rise the temperature so that the cube will expand, but the volume, the length immersed will remain same. Try to follow the diagram. What is the relation between? Okay, this H, I'll write it. It's a cube, solid cube. Side length, how much it will be? Equal to L. So what is the relation between alpha and gamma? Alpha and gamma L of the liquid. Density of liquid, rho L, gamma, let this be alpha S. How alpha S and gamma L are related for this particular solid and the liquid here. Theta 1, this is theta 2 degrees Celsius. Find relationship between alpha s and gamma L. If length of cube immersed in liquid remains same. Okay, in a simplest way I'm putting, okay, let's do one thing. So initially who will balance the weight of the solid? Now I'll rise the temperature. What will happen to weight? The weight will remain as it is, no? Okay, of course, buoyant force will change. Let it be. Are you seeing something area? No need of diagram, you can proceed in this way. The H remains same. Try to look at the H parameter here. So shall we put directly? I'll get into the problem. FB equal to FB dash. Because the weight of solid will not change, no? The weight of a body will not change. WS means, or if you're getting confusion, let me write mg. Mass will not change, we all know it. See, the cube will expand such that the length immersed inside the liquid will not change. That's the basic condition. Volume of cube will increase. Are you able to, all of you, able to see the volume? It is of bigger size, no? No, cube will expand. The liquid will also expand, but the length immersed inside the liquid will not change. Okay, let's get into the okay, any formulas can we write? Density of liquid, volume immersed should be equal to, the density of liquid will change. Density of solid will change. Let it be, we are not bothered. The new volume immersed Vi dash. Okay, if you want, I'll bring G also. So this will be rho L Vi. What is Vi? Initial volume immersed, area of cross section, L square H it is. Volume immersed. Okay, G will get eliminated. Rho L dash. So what is rho L dash? We can write it as rho L 1 plus gamma L delta theta. I'll slide a little bit up. No, what is Vi dash we should write? We should write A dash into H, no? So what do you mean by A dash? The volume, the area of cross section has to change. What is A, or here we'll write it A. So what is A? Area of cross section will be L square. We know cube. So what is now this? This will be A dash. Okay, G will get eliminated. So therefore now this will be rho A H. H will get eliminated. A is equal to rho L. Now what is A dash? We can write it as A into 1 plus 2 alpha S delta theta. A gets eliminated. So rho L also gets eliminated. Let me write this one. So 1 plus gamma L delta theta equal to 1 plus 2 alpha S delta theta. So what is gamma L? Equal to 2 alpha S. If this condition is satisfied, this H will not change. Length immerse will not change. So don't say that volume immerse will not change. Find the relation between alpha s and gamma L if the length of cube immersed in liquid remains same. Length of cube immersed. Getting now? So we do get several conditions. So what I suggest, draw the appropriate diagram. No need to go for exact. Now you tell me like for volume immersed not to change, what is the condition? Gamma L should be equal to gamma S, 3 alpha S. I can put any conditions here. Just you try to go through it. Let me take next condition. Yeah. Let me introduce to the so these are the springs are there.